do that? Does it do it every time I go into full screen? It's quite annoying. Okay, I won't go into full screen then. So this reads nicely, but it blocks. If this JSON file is like 100 gigabytes, which is kind of ridiculous, but it's possible, then this function is going to take forever to run, and it's going to hold everything else up. So let's write some kind of deliberately blocking code. Let's go to here, and in our, let's actually create a sync.js, sync.js. So I want to have a function called block for some time. We're going to take a duration, duration in milliseconds. I've just been ranting today about names of things, and so I'm going to be very explicit. We're going to have duration in milliseconds. And what we can do, start time, we can use date.now to give us the start time in milliseconds, and then we can have current time, or actually we can do it slightly differently, while start time plus the duration is less than date.now. Yeah, I think if while less than, I see this is why while loops are confusing. Finished blocking. So let's call it, I think I've messed it up, but what is going to happen, this is going to execute immediately because this loads up this file and executes this function because we call it down here. It should, although I think I've got this wrong, start time is greater than, isn't it? Yes, I've caught it. While the start time plus the number of milliseconds we want to wait, while that is still greater than date.now, so it keeps running this, and date.now is slowly going to increase every millisecond, then we log out finished blocking. So let's have a look at this. There we go, finished blocking. So you can see Chrome is saying, we're actually still parsing this JavaScript file, we're still executing it. So it takes 1 second to log out finished blocking. Now if we want to do a whole load of different tasks, and they take a sort of varying amount of time, calls finish blocking, then again, then again, then again, then again, and the whole time Chrome is saying your page still isn't ready. We're still figuring out what this JavaScript file is doing. Has someone just requested to join, or they've joined? Well done, you've made it. So this is blocking code. The browser doesn't want you to do this at all. In fact, Lighthouse, I don't know if I've shown you Lighthouse before. And can I run serve? So Lighthouse is really good. It generates a report for all these kind of different, let's just do desktop, all these different categories, and it gives you a kind of score based on these, a bunch of tests that it runs, and it's really nicely done. Once you guys have sort of projects and you want to work on improving them, I encourage you to use Lighthouse. Look, as page load time increases from 1 second, oh, it's too fast for me to read. Even while it's doing this audit, 1 megabyte takes a minimum of 5 seconds to download. Look, it's given up. It actually just gave up. Resources are blocking the first paint of your page. Yeah, I think I wasn't really expecting that, but it certainly just, yeah, we're recording the trace over your page load. I wonder why that didn't work, because you've got nothing on the page. Or perhaps let's comment all of these out and just have one. But it's going to tell us, okay, fine, best practices. Wow, we got 100% on best practices, but performance, it's not even scoring us. First contentful paint is 1.3 seconds, so it took 1.3 seconds for the JavaScript to finish executing. That's total blocking time. That seems wrong. But anyway, clearly something's gone wrong. This is a bad website that it takes so long to finish running that JavaScript, and now it's going to take even longer. Finish blocking, finish blocking, finish blocking. Okay, so we're going to do something similar to this, but a slightly more useful version. So do something later. We're going to have a duration and a callback. This is where we get to call back hell. So we have our wait timer, and then we call the callback. So now, do something later, 1000 milliseconds, console log. Now we are doing this. Okay, that's going to look so bizarre. Then document append document create element button. So we're waiting for all those finish blockings to happen. They take a whole bunch of time, and then it says now we're doing this, and oh brilliant, document.body.append, and we've got to do that. We've got to wait all over again, and it's clearly not a very good website. And finally we have our button. So that's an example of code that you don't want to write. You don't want to write this. Sometimes you're going to write a while loop that actually takes a fairly significant amount of time to run. Sometimes you're going to be reading files like we were in Node, but that is where asynchronous functions come in, and the most simple are set timeout and set interval. So you've used these before. We've used these to kind of simulate, I don't know, interactions in the page and things like that. But set timeout and set interval, they should be very familiar and kind of look pretty familiar, pretty similar to these functions that I just wrote. Do something later, wait a period of time, and then do this. That's all set timeout is. The difference is it's asynchronous. So set timeout executes some code after a specified time has elapsed. It takes the following parameters, and then there's nothing there, whatever. It's got a callback and a duration, just like that function we wrote. So here we can set timeout, set interval. Okay, fine. These slides are bizarre. I don't think I made them. So set interval, pretty similar to set timeout, but it happens every duration. So set timeout just happens once after the duration, set interval happens every 1000 milliseconds in this case. So here we've got a counter, we've got a little stopwatch. It is counting a number of seconds from when this was first called. How can we stop it? It returns an ID, and we call clear interval, passing in the ID, and in this case, if this is the exact code that ran, I don't think anything would happen. It would never count up because we start the interval and then immediately clear it. So it's unlikely that you're going to do that. Let's build a stopwatch. So I think we should just go and do it. Let's just go build a stopwatch. That's going to be far more interesting, isn't it? Okay, so we're going to have stopwatch.js and stopwatch.js ID is stopwatch. So that's all we're going to have. We're going to create all the elements we need for the stopwatch in stopwatch.js. We're going to this is the first lesson back on building front-end stuff, so we're going to go over creating all of those elements and doing all of that. So we get our existing DOM elements, stopwatch container is document query selector, remember, query selector stopwatch, and I am going to remove that sync stuff because that's silly and it's going to be annoying. Okay, so now stopwatch container is saved as a global variable. We have access to it in stopwatch container inside this file, but also everywhere in our app. So we want a function add controls. Let's say add controls, and we're going to call add controls immediately. Start button is document create element button. Start button in a text is start, and we're going to have stopwatch container dot append the start button. Start. I suppose it doesn't really matter. The start button and stop button. Why does it not autocomplete? Okay, we've got two buttons. This code is running. We're finding the element in the page. We're adding them to the page. We also want timer display. I don't know. Document create element p timer display dot inner text is, let's just say 0000 for now. Okay, that'll do, that's a stopwatch. So now when we press start, we want to start a timer that runs every, what do we want to do, 10 milliseconds or that's, yeah, something like that. So let's have start timer, set interval, every 10 milliseconds, console.log timer update. So on the start button we can add an event listener, a click event listener, and we can call the function start timer. We see a load of console logs in our console. Let's create a timer, I don't know, value of 0, and let's say timer value plus 10 because it's 10 milliseconds. Timer update with the new timer value. Now we start and it counts up. It looks like it's roughly a second. Is that what we want? That's 1 second, and then yeah, okay, I think 10. That's fine. But every time I click start, it's creating a new timer. So we don't really want to do that. We're going to have a sort of stopwatch state. Stopwatch state is stopped, and inside the click, if stopwatch state equals stopped, then start the timer, and in start timer we set stopwatch state to counting or timering, something like that. So we click start and I keep clicking it, and we're not getting a whole bunch of new timers that are starting. Okay, so now the stop button, we want to clear that set interval. So stop button dot add event listener click. Let's use that stopwatch state. If stopwatch state is counting, then we want to call a function stop timer. So event listeners are also asynchronous code. They're something that, even though this function call happens now, this function actually runs later on at a kind of unspecified time in the future. So it is also asynchronous code. So you should be familiar with event listeners, and that hopefully allows you to kind of understand asynchronous code a little better. So here we actually want to store the interval ID, so let's call it timer ID. Timer ID equals the return value from set interval, and now we can call clear interval passing the timer ID, and we call stopwatch state and we set it to stopped. Start, stop, start, stop. Okay, it's starting from 0 every time, but it works. I can call that as many times as I like. I can call stop as many times as I like, and it's fine. It just works. Let's update that timer display, and what we can do is pass a callback through to start timer. Update display callback. This is going to receive an argument of update display callback. It's going to be a function. We're going to pass it the timer value instead of logging it out. And now in here, inside our controls, we have access to that timer display. So timer display.inner text is timer value dot toString. You don't really need to call toString, but it's good practice. Let's see what happens. It kind of works. So this is asynchronous code. It is using set interval. It's not blocking. We can create a whole bunch of these. So I suppose we could call add controls, set interval, add controls. Is this going to work? If we call that every 2 seconds, what's going to happen? Okay, it's going to do it on. Well, oh, I did set timeout. Well, some funky stuff happens, but like it sort of works. They all kind of stop because there's only one, but it sort of does it. So while this one set interval is running, while this set interval is running, everything else still works and we can still interact with the page. That is the good thing about asynchronous code. It says, okay, go off and do whatever you need to do, and later on come back and run this, rather than just keep running the same thing over and over again and don't let anyone do anything on the page. Okay. Promises. So, well, I kind of know the answer to this, but this one doesn't have any question slides in here. So, does anyone have any questions? I was hoping that was going to be 2 questions in the chat there, but no such luck. Daniel has one.
You're going to start explaining what promises are.
Yes, yeah. Promises are next. Yeah.
Oh yeah. No question.
Okay. Well, let's move on to promises. So, I don't really like this, but this is the official explanation, and I'm just looking at these slides, and there's that, and then to the code editor. So there's not a whole lot about promises, but it's always better to demonstrate anyway. A promise is an object that represents an intermediate state of an operation. In effect, a promise that a result of some kind will be returned at some point in the future. You don't know when the operation will complete and the result will be returned, but when the result is available or the promise fails, the code you provide will be executed in order to do something else with a successful result or to gracefully handle a failure case. That's a very wordy explanation. But a promise is just essentially another way of writing asynchronous code that traditionally used callbacks. So with set timeout, you pass it a function that it's using as a callback. It's going to say, okay, give me a function and I'll call that later on. But there can kind of be nothing can go wrong with set timeout, but pretty much anything else, something can go wrong at some point. So you need to pass a callback to handle when it's successful, and a separate function to handle when it is unsuccessful, when something goes wrong, when there's an error. Maybe you want to pass another function that always happens, regardless of if it was successful or if it was a failure. Maybe you want to pass something, like you kind of get the picture. You could potentially pass 3-4 different callback functions for different stages of the asynchronous process. So a promise pretty much just neatens up how you deal with that stuff. At some point in the future, in other languages, it is called a future. I think in Python it's called a future. But promises or futures are essentially a way to say, okay, something is going to happen at some point that we don't necessarily know, and when that does happen, do this. So the syntax for a promise is, we have this function, your async operation. So you have a function that returns a promise. That promise has a function called then. So this is one reason why I really like promises. The word then means something. Do something, then do something else. It reads really nicely. So do something, and that might take some time, and then do the next thing. And you can chain these. So do something, and then do something else, and then do something else, and then do something else. And then we have a catch at the bottom. So if anything goes wrong in any of this chain of thens, catch gets called just like a sort of try-catch block. And there we can handle anything that's gone wrong in any of our promises. If we receive an error from a server, if the file can't be found, if the user interrupted our operation, then we can handle our error gracefully. So that is the promise syntax. So we're going to build, I'm going to promises. I wonder what can we do? We can do something a little bit fun. Move stuff around on the screen. So let's have div class mover. It's going to be a thing that moves. And let's see what that looks like. Okay, so there's this green square. I want to click on the green square. I'm going to have it move over here, then back to where it is, and then destroy itself. I should probably stop that set interval for the stopwatch. Okay, so in promises, we're going to say mover is query selector with the class mover, and let's just check that we have that mover. No, we don't. I think that's because I haven't added it here. Great. So it's always really important to just check very simple stuff, and I've called it mover.js. Now we're going to call it promises.js. Okay, so what we're essentially going to do is update the style of this. So transform, translate. Yeah, we're going to update these values. So you can see it's kind of moving over to the right, then we'll move it down, and then we'll move it back, or I don't know, we'll figure out how to do it. So we're going to have a function called move_to. It's going to take an element, and it's going to take an top and a left target top, target top, and target left, target top, target left. So over and a duration, over a period of milliseconds, in milliseconds, over a period of milliseconds, this element is going to move to this target top and this target left. So what we can do, we can transform, translate 0, or maybe we can do top. Position absolute. Yeah, I think that's going to be easier. Okay, so in here we want and let's have promises position relative. Okay, cool. Position absolute, top. Okay, so we're going to have current top is pass int element dot style dot top, and current left pass int, which takes a string and converts it to an integer. Let's log out these values, current top and current left, and so we want to call move_to with mover, pass in that mover element. Let's say we move it to target top 100, target left 400 over 1000 milliseconds. I know they're not used yet. Okay, great, we have now. So, or 0. So what this means is if the value on the left is false or falsy, like nan is, not a number, we say, okay, use this or this. And in this case, it's falsy, so it's looked at this one and it's gone here. If it does in fact have a value and it's truthy, it's going to take this value. So now let's call set interval move ID, set interval every 10 milliseconds or 16 milliseconds, which is 60 frames a second. We're going to say current top plus 1, current left plus 1, if, yeah, okay, whatever. And then again, let's log out current top and current left, see what happens. Okay, so they're constantly increasing. if current top is greater than target top, let's set current top back to target top. If current left is greater than target left, then let's set it back. So now they should increase. Target left or top, or whichever one it is, I can't remember, goes to 100 and no more, and target, the other one, goes to 400 and no more. So here, if current left is target left and current top is the same as target top, then we can clear interval using that move ID. Oh, I'm not logging anything out, that's why it's stopped. So we can see they keep logging out, and then hopefully when this reaches 400, it stops. No more logs. So we're happy with those numbers. Finally, we can actually update that element. Element.style.top equals, we interpolate, we say current top pixels, and the same for left. Oh, I've said type. Okay, a little bit weird, but it does move. It doesn't take duration though, that's going to be tricky. I don't think I can be bothered to figure out how to do duration. Well, we can come back to it. Ask me a question later on if you want me to do duration as well. Okay, so it moves to the target, but then what if we want to say once you have successfully reached your target destination, then move somewhere else. So what you might be tempted to do is do some kind of set timeout and be like, okay, I reckon it's going to take 3,000 milliseconds, and then I want you to move to I don't know, to 150, 450, and I'm doing that because I have realised we can't go down, we're always going up, but never mind. So, okay, I've done that wrong because it took longer than 3,000 milliseconds, so let's whack that up to 5,000, and that takes still not long enough. 5,000, 6,000. So clearly this is not a very good way to do this. We're just completely guessing how long some kind of animation or some kind of interaction is going to take, and then we want to, I suppose we could have the set timeout in here. So that one's going to take much less, so like 2,000, and then move that to 550, something like that. So it moves down there, then we start moving again and call another set timeout, and then it kind of stops and waits because we've got the timings a little bit wrong, and then it moves all the way down. So this starts to be callback hell, so we don't like it. What we want it to read nicely. Move to there, then move to somewhere else, then move to somewhere else, then move to somewhere else. That reads really, really nicely, much better than this. It also is not reliant on these random timers that we're just making up. So let's say mover. Let's actually do this random times 200 math.random times 200. So there we're just picking two random top and left coordinates. Let's first make this work, or attempt to make this work, going down as well. So current top plus equals 1 current top. So if current top is greater than target top, then we're going to plus minus 1. Whoops. And we're going to plus minus 1, otherwise we're going to plus 1. And the same thing with left, is current left is greater than target left, then we're going to minus 1, otherwise we plus 1. Current top is greater than target top. We can't really do that. If current top is greater than target top, how's this going to work? If current top, I know, we're going to do it a bit different. Current top is greater than target top, then target top, no, current top minus 1, and then if current top equals target top, we kind of want to stop it. Oh, this is harder than I thought. We can kind of clamp them. How do we do this off the top of my head? Okay, current left, target left, and current top, target top. Let's do it easy way. Stop, top, false, left, stop, left, false. If current top is equal to target top, stop top true. If it's equal to target left, stop left true. And then here we only do these if we don't want to stop the top and if we don't want to stop the left. So if the top is continuing to move, then change the value. If the left is continuing to move, then change the value. If it becomes the same, we want to stop moving it. If that one becomes the same, we want to stop moving it. And then if they're both the same, we want to stop moving. We want to stop calling this set interval completely. Yeah, maybe that'll work. Okay. I probably should have tested it. Set timeout. Math random. What is going on there? Move to. Do I need to increase that? What's going on? Okay, well, I mean, maybe it works. We can come back to that. So, inside here, we now want this to return a promise. So, one way we can do this is actually wrap everything in a promise. So, return a new promise, and the promise kind of function, the class, takes a callback. The callback takes an argument that we call resolve. So a promise gets resolved when that asynchronous thing has finished happening. So we can put all of this into here, and at the same time at which we call clear timeout, that's when we call resolve. So move to is going to return a promise. Move promise is move to, and we can say console log move promise. We can have a look at what that is in the console. It's a promise and it's pending. So it's currently pending. I'm going to close it and open it again. Oh, it was evaluated just now. Okay, but once this finishes moving, oh, is it just never going to finish moving? What have I done? Current top is greater than target top. Oh, because we're always doing that. What, stop top? Current top plus equals 1 if current top is target top. So this promise is actually never getting resolved. Current left is target left, current top is target top. What have I done? If we want to keep going, stop top please, stop left please. Okay, they never actually fire. Current top. Really? Greater than target top. Always increase it by 1. Fine. Fine. I didn't want to do this. Current top and target top. Oh. Oh. Idiot. Okay. So, on math.round, because I was using math.random, it was actually picking a random float, so 148.924 blah blah blah. So we're going to round those values, and there's stop top please and stop left please. Okay, finally. Okay, so it moves, we have promise pending, and now I'm going to open the promise and it's going to evaluate again. And the state of the promise is now actually fulfilled. This is slightly confusing because the promise, the terminology is confusing. the state here says fulfilled, but actually we generally refer to it as being resolved because that's the name of this function. So the promise has been resolved because we've reached this destination, and therefore not then. Oh yeah, we can do then. So we can call then on move promise. So move promise is just a promise, and we can actually call temp1 dot. So we can see the different functions that we have available to us. We have catch, constructor, which we can ignore for now. We have finally and then. Then is for a chain of things. We can call that multiple times. Finally is when either catch or then has been called, the very last thing to happen, we want finally, and catch is when something goes wrong. So we're going to take that promise, we're going to call then on the promise and pass it a new function. So we've just written an inline arrow function here, and we're again calling move to. So move promise, then move to somewhere else, then move to somewhere else, then somewhere else, then somewhere else. So this should move about the screen a whole bunch of times. And it doesn't matter how long it takes, it's only going to resolve that promise once it has reached the destination. What we could do if we wanted a little delay before it moves on, we could have a sort of 100 millisecond delay before it moves on. So it hits this, it calls set timeout before it calls resolve. So it's a little bit hard to see. So it waits there, then it waits there, then it moves, then it waits, then it moves, then it waits, then it moves. A bit odd, I'm not really sure why you'd want to do that, but this, although because we've got quite a lot of code here, it's formatting it a little bit strangely, but we have these thens, we have a function called move to, which again reads very nicely. Move to, we don't even need to save that promise. Generally, you call a function which returns a promise, and you immediately call then after the brackets of that function. So move to, then move to somewhere else, then move to somewhere else, then move to somewhere else. So it really reads much better than using those callbacks that we were previously, or using timers or anything like that. So promises I really like, and I use them a lot because of animations. So I make games, and games use animations. Websites, not so much, but I still think if you ever want to animate things in a relatively complex way, then promises are your friend. I know you can have CSS animations, but if you ever want to do anything a bit more dynamic with JavaScript animations, promises really work very nicely. However, the vast majority of the time you interact with promises, you're going to be using fetch. So for now, do you have any questions on promises specifically? But bear in mind, it's slightly more confusing. Like it is unlikely you're ever going to be writing new promise resolve. You're not going to be doing that. The vast majority of the time, you're going to be calling a function which does return a promise. So you have to get used to this idea of function returns a promise, we call then, you pass a callback to then, and so on and so on. Bear in mind, you don't really have to worry about this. So if you've got any questions on promises, Daniel, you literally said you had a question on promises, but was it to do with fetch, or has it been covered? Are you still there? Is anyone still there? I just wanted to know what it was. Okay, right. Okay, that's fair enough. Okay. And also promises really are quite confusing. They take quite a long time to get used to. So don't be disheartened if it doesn't really make sense right now. Okay. The fetch API, we covered kind of requests and responses in the previous module, and we did a little bit of fetching, but it was really only to demonstrate the requests on the back end being received and sending responses back. So we're going to learn a little bit about the fetch API right now. So we can send network requests to the server and get new information. The fetch API provides a JavaScript interface for accessing and manipulating parts of the HTTP pipeline, such as requests and responses. It also provides a global fetch method that provides an easy, logical, that's debatable, logical way to fetch resources asynchronously across the network. So I actually just looked at this in carbon intensity API, which we're probably going to try out a bit later. And this is, I don't know if you can see, this is jQuery Ajax, so not Ajax for you football fans. jQuery was a library 20-25 years ago that made working with JavaScript a bit better. All browsers were really very different, and jQuery brought everything together, and it gave us some nice, helpful ways to make requests. Ajax stands for, I can't even remember, asynchronous JavaScript something something. What does Ajax stand for? Ajax JS. Asynchronous JavaScript and XML. I'd forgotten that that's what that means. That's nuts. So it was kind of invented when the web worked using XML data instead of JSON data. But anyway, you make an Ajax request, usually using jQuery. So we call jQuery, which is what this $ means, .ajax. We pass it this object, and here is our success callback. There's a success callback. We also had an error callback. We also had a always callback and a something else callback. And this is how we made requests. Then fetch was introduced to unify and create a nice kind of replacement for this, because this is not built into browsers. You had to include the jQuery library, and the built-in way for browsers was not very nice. So that's why fetch exists, to make it simple. So we call the function fetch, we pass it a URL, and then we get the response from the server. In this case, we take the response and we want to convert it from JSON into JavaScript objects. And then we're going to chain these then we have that data on the next line. So this is using a promise. Fetch returns a promise. On the next line here is something that we didn't see in the previous example with promises. We get the value that was used to resolve the promise. And so inside this function, we have that value. That value is a response object. We'll look at that in a minute. We convert it from JSON into data that we can use. So on the next chain of thens, we have a data object, and then we log it out and we can view it. So again, I think we talked about this in the previous module, but we have get, post, put, head, delete, patch, options, connect, trace. Most of these you're not going to use. By default, fetch makes a get request. We tend to also make post and delete requests and patch requests. Everything else, I don't think I've ever used any of the others. Occasionally put, but most of the others you don't really need to worry about too much. Response headers, we don't really need to talk about response headers. I mean, in a map-like headers object, that doesn't mean anything to you. With our request and the response we get, we can include headers. So it is before the body, before the content of our request is received, the server can access the headers so it can figure out what it's receiving. And the same thing with the front end. So the front end can look at the headers of the response before it looks at the body. So here's an example. We can get the content type header, and the value of that header here is application JSON. We can iterate over them all. We'll look at that in a minute. It's not that important right now. And now we're going to make some requests. So we want to load up fetch. We're going to have another div response, and in fetch response container query selector response, I think. Okay, so let's make a fetch request to date. I'm not entirely sure what we get back here, but let's just do that. Let's just call fetch with the date. We don't see anything in the console, we don't see anything in the HTML page, but here is where the network tab of your DevTools comes in really handy. Now you are making requests from your front end to your back end or someone else's back end. We can actually see here are the files that it's loaded up, but also here is a request that we've just made. So we've made a request to API carbon intensity or intensity date. We can automatically see this preview of the data. It's really good. Absolutely use this network tab. It's honestly one of the most useful things, and it kind of took me a while to find it, and it takes my students a while to find it, or it used to, and then I started telling everyone use the network tab because it's really useful. Otherwise, you'll be adding console logs in all over the place to see the data. You don't need to, you can just access it directly in here. But that is what we're going to do. We're going to log out the data anyway. So once that request has been fulfilled, we get a response back from the server. So in our network tab, we get raw response data, response preview, headers, but in the console, we can see we get an object that is a response. It's an object of the type response. We can see there's some headers. We can see it says OK true, status 200. So the URL, we can get some information about it. But this body getter, so we want to get access to the body of this response, what the server has sent back. If we try to access the body, it gives us a readable stream. Let's look at that. We can call pipe to or pipe through or something like that. It's a little bit confusing. So that body is not how we access the body of the response. If we have a look at some of the functions that are available on our response, we can see we have text, we have JSON, we have form data, blob. So text and JSON, they're probably what you're going to be using the vast majority of the time. Blob is how files are sent. Files, if someone sends an image file, you want the kind of raw data. That's what you use blob for. But we're going to use JSON. So JSON is a function on the response. So and then console.log response.json. Now, I said it before, I kind of explained it, and it is going to be a trick question. What do you think? I want someone to say something, even though I've just told you it's a trick question. What do you think response.json returns? Bear in mind, this is the data that we're getting from this API request. Here it is in JSON format. What does response.json actually return? Oh God, I'm turning a light on and kicking everything over. I want someone to answer me. Someone to be the sacrificial lamb. Okay, so if you were to guess what a function called JSON returns, I'd hope you might think something like the JavaScript object, or in fact the JSON. So JSON and JavaScript objects are two different things. JSON is a string, JSON is that,
yeah, and
a JavaScript object is that. So we can call JSON.parse to take some JSON and parse it into a JavaScript object. So I'd kind of hope that you would expect JSON to return maybe either this stringified version or the parsed object version. However, slightly annoyingly, response.json actually returns another promise. So I know it's annoying and confusing, and I forget this all the time. But fetch returns a promise, and that makes sense because we're getting data from a server, and a server might take some time. But JSON, you think it's pretty much just calling JSON.parse, so why does it return a promise? I'm sure I've looked it up before, I don't entirely know, but I think it's because if it does respond with like 100 meg of JSON or a huge amount of JSON, then it does it asynchronously, and therefore it kind of says, okay, I'm going to go away, convert it into an object for you to use, and then I'll tell you when it's done. So the vast majority of the time you use fetch, you're going to do it like this. Then we have another then. So we call fetch on one line. On the very next line, we say convert the body JSON data into a JavaScript object. That returns a promise, so it takes, say, 1 second to actually convert that data. And then on the next line, in the next then, we actually have the JavaScript objects. So we reload the page. It takes about half a second. Let's in fact put ourselves on slow 3G. So it takes like 1, 2, it took 2 seconds, it took 2.16 seconds. But meanwhile, this block was happily moving around the screen, and we have this data. We have the JavaScript object that we can actually do something with. So we can chuck it in the response container, display response. Response container dot inner text. We're actually going to say JSON stringify data. Okay, so we get the data from the back end, we receive it, we display it on the page. It's probably a bit silly, so let's say data dot-data. I'm going to pass only the data, and this is like, I don't know, dates or something. Dates dot for each date, we're going to create a div, create element div, inner text from date dot from to date dot to, and then response container dot append div. Okay, so this is fetch. Now, if something goes wrong, we can add on a catch function. So we'll just, in fact, document.body.append button. Okay, let's just chuck on a button. Oh, no, let's make it a bit nicer. Error div dot style dot background is red. append error div and error div inner text is error. Let's just have that error up here. Now we can, if response is okay, then we return the JSON. So remember we looked at the response object. It has a property called OK if everything was fine. Else we throw, oops, something went wrong. So we throw an error or some kind of value. It gets passed all the way down to catch, and how to demonstrate this, let's just make some kind of bad request. So we get a 400 from here, and therefore it actually says type error failed to fetch because we didn't even hit this then. It just, yeah, well, I mean, I'm slightly surprised at that, but I think that's the server's fault really. Opening new tab. Oh. I'm a bit surprised. Strict origin when cross origin. Anyway, it doesn't really matter. We've got an error. We've hit this catch. We're displaying it in here. And that's a kind of nice way to handle that. It could go wrong in any of these thens. If it goes wrong in any of these, this catch gets called, and we handle the error gracefully. Okay, so that is sort of fetch with promises, a kind of introduction to fetch. On Thursday we will, using APIs, I'm pretty sure on Thursday we're going to look at posting data, sending data with fetch, and kind of fulfilling a full RESTful API. Yeah, Mushtaq said, is it in form of JSON? Good, that's the correct answer, but it's the incorrect answer. It's the answer I was hoping you were going to say, but as we now know, it's actually a promise. Questions about fetch?
Sam, did you just say that on Thursday we can send data with fetch?
Yes, exactly. Which makes the name of fetch really confusing. Is that your point? Is that what sort of just blew your mind?
I was wondering if it was like a grammatical slip of the tongue or something.
No, I imagine there is some sort of place where you can read why they called it fetch, but I think you generally do get data, but I agree that it is a pretty confusing name because in English it does mean to get something. So sending something with fetch does feel a little bit wrong, but yeah, so we use fetch and we just pass some options to it to allow us to send the data to the server.
One more question. Do you think that the programmers get together and decide to make things as difficult as they can be for people that want to learn?
I think that's fair enough for how things used to work. I think 20, 30 years ago, very little thought was put into what's the phrase? quality of life, sort of, oh yeah, developer experience. So user experience is this sort of theory of being user focused in all of your websites. You're constantly thinking about your users, but there's a sort of flip side of developer experience that modern frameworks and modern APIs and modern browsers, everyone is thinking about the developer experience as well, because if it's a really bad experience to work with some technology, developers aren't going to work with it. No one's going to adopt it because it's just such an unpleasant process. But absolutely no one thought about that 20, 30 years ago. So all the browsers were a mess. That's why jQuery came along, and jQuery was great, but it kind of got too big and ended up being a kind of hindrance. And the browsers kind of started to realize that we need to make life easier for developers, so that disappeared. But yeah, I think it's a fair point, and certainly developers sometimes are just trying to be too clever, and it's not worth it. I think clearly the people who build Chrome and who invented JavaScript, they know what they're doing. They're far smarter than I am. But there is, I regularly see this kind of bell curve of kind of beginner programmer, mid-level programmer, and senior programmer. And beginner, it's all about writing like simple, easy to understand code, and that's really what your priority is. It's just you want to be able to understand it, and that's what counts. Then mid-level, you're like, oh, I've got this, I know what I'm doing. So you write a sort of ultra complex code that does super clever stuff. And then senior, you go back to just writing simple, easy to understand code, because that's actually way more important, because it is, you realize that you're not really writing code for computers, you're actually writing code for humans. And so you want to write code that your colleague can understand in 3 weeks' time, or when your colleague asks you about it in 3 weeks' time, you can kind of figure it out. So it's a good point, and it's one that you should kind of take forward. You want to make stuff easy to understand. That is actually way more important than anything else. Okay, so let's now look at a sort of new way to write promises. Async Await was added, I don't know, ES6 or something. These days, it was probably 5 years ago, which is quite a long time ago, but it feels like a sort of relatively new addition. And it actually doesn't do anything different. It's just special syntax that works with promises, so you still got to use promises, but it does it in, this says, a more comfortable fashion. It basically makes it read like synchronous code. So synchronous code, on the first line, we have do something, and then it doesn't go on to the next line until that thing is finished happening. With promises, we've got this then and the callback in the then. It's still a little bit confusing. It's better than callback hell, but it's still a bit confusing. So to use await, your function should be async. You can ignore that. So this is an async function. Get data equals, we have our normal-ish arrow function, but with the word async before it. We are marking this function as asynchronous, and then we wait for this fetch to resolve, and whereas when we're using then, the value kind of gets passed through to the next function, it actually gets stored in a variable, and it doesn't move on to the next line until this promise has resolved. So it all works on promises. If you're using fetch, it's fine, but if you're using your own function, you need to be returning promises, but it reads a little bit nicer than promise dot then dot catch and so on. So it's not really it's not a better way necessarily. I use a kind of a mix of async await and promises, I think, but we'll refactor what we've just done into async await just to make it a little bit nicer. So async await, async and async await. So here this is going to be async. Okay, so first I kind of skipped over this one. To use await, your function should be async. So what we can't do, response equals await, so this is how we would write it, then response, then kind of response JSON data equals response JSON, then display, and in fact that's a promise, so we await for that and then we can ignore the catch. That's how we would write it. So it's much neater. Okay, I've got rid of a load of code there, but on one line we wait for the fetch to happen, on the next line we wait for the JSON, and then we call display response. In our console we get an error. Await is only valid in async function. So it's a bit annoying, we can't use it inside this kind of global scope. It has to be inside an async function, which is why many sites have some sort of init or something, initialize function, and in here we can, because we are calling it as an async function, we are denoting this function to be asynchronous, so it's going to use some promises in here, it's going to use some await keywords, and actually it returns a promise. Response container has already been declared. Await container, whatever. Display response has already been display. Await response. We want date. I can't quite remember what the oops. Is it dates or date? Oh, and then we have to call init, of course. Okay, failed to fetch date, it's just date. We'll get there eventually, there we go. So, it needs to be inside an async function. So in this case we can just call fetch, but in here we could just call fetch, but we can't use async await in the global scope. So that's why we've wrapped it inside this asynchronous function, and we have to call the function to kind of kick everything off. So that's arguably nicer. One reason why it's not necessarily perfect, and I actually don't like it, is how you have to handle errors. So I don't really think we've looked at try-catch in this course, because handling errors is not very exciting. So we tend not to dwell on it very much for beginners. But try-catch is used for sort of normal JavaScript code where something might go wrong, and so we actually do the same when we're using async await. So we have everything inside a try-catch block. So try and do these things, if something goes wrong, console.error, we display that error somehow. And I don't really like this. I actually prefer to have it down here in a catch function at the end of the fetch. But with Async Await, we can't do that. So we have to wrap everything in a try-catch block, which makes it a little bit less graceful. So it's kind of up to you. I think beginners generally prefer Async Await because it looks like normal synchronous code. But the benefit of you guys learning JavaScript first, or kind of learning all of this at the same time, JavaScript has loads of syntax like this. So having these inline functions and an inline function like this, if you're used to that from for each and map and filter and everything, then it's not really anything kind of new to you. People coming from other languages and who aren't yet familiar enough with the sort of idea of callbacks, they really struggle with promises and this sort of syntax. But hopefully, because you should be relatively comfortable with callbacks by now, this isn't going to be like completely crazy for you. So that's Async Await, that's promises. Mushtak has a question. Can we say in sync promises programs don't wait for promises to resolve, carry on, while in async promise has to be resolved? Yeah, exactly. So in this one we'll say fetch, then this, then catch. Console.log after fetch. So it actually logs out after fetch before it does all of this, which is this response actually failing. So even though we're calling it on line 13 and then we're calling this on line 28, this happens first. And then on here, after fetch await. This one does actually happen after the, it's sort of confusing, but we're going to get console.log data. So after fetch here, we don't actually have the data. Here's the request from this one, but here's the data from this request, and this logs out after that promise has resolved. So exactly, it's waiting for the promise to resolve before moving on to the next line. But notice how in here, I'm going to remove the try catch because it's a bit easier to kind of read. Notice how in here we're not returning anything. However, console.log return value from init. So we're not returning anything from the function, therefore you'd expect this to have the value of undefined. But we actually see we have the value of a promise. So as soon as we call async, this function actually now returns a promise, and we can see it's now fulfilled, and the result, the value used to resolve that promise is undefined. But if we return the data at the end of the function, it's pending, then it's fulfilled, and then the promise gets resolved with that data. if we say, I don't know, the string data, we can see it gets resolved with the string data. So even though we weren't returning anything here, it does return a promise, whereas now we are returning something, we're returning that data, the promise gets resolved with the data from the server, with whatever we're returning from the async function. So I think that is it, real life example. There's no more slides. So does anyone have any questions on promises, async stuff, fetch? Okay. Daniel, you unmuted.
Yeah, I was just going to say, I think more questions will pop up the more we start to use Async Await and all this.
Yeah, it is quite confusing at first. It took me a very long time to get used to promises. So yeah, don't worry if it takes you a little while. Luckily, fetch is kind of the only place you're likely to use promises. There are other libraries that do use promises, but I think I personally use promises more than most people, most web developers certainly. So you want to focus on fetch and promises within the context of fetch. So don't worry too much about creating a new promise and it receives a callback and you have the resolve function. That's all kind of extra stuff. Okay, thanks very much everyone. Hopefully